today's problem from complex number, and the problem is so that log I base I, this is equal to 4n plus 1 by 4m plus 1, where m and n are integers. Also we have to prove log minus 2 base 2, this is 2n plus 1 into pi I by log2 plus 2mπi, where m and n are integer. Here two problems we have to prove. Here we use two general property of complex number. The first is general value of logarithm. What is the general value of logarithm of z, any complex number? We already says in the previous class. Log z, this is the general value of z. We denote it by capital L, log, capital log. Okay, this is log of mod z plus I into 2n pi plus argument object. Okay, and here n must be belongs to set of integer. And the second property is, which is the definition of exponential function, which is given by if z, this is equal to log b base a, then the definition of exponential function is a to the power z, this is equal to b, right? Now for the first problem, here we first let z, this is a complex number, capital log of I base I. Okay, now using the definition, this definition, we may write I to the power z, this I base I to the power z, this is equal to I. Okay, now we take on both sides logarithm, that is z into log I, this is equal to log I, right? And now we try to write I, this is equal to cos pi by 2 plus I sin pi by 2, because cos pi by 2 0, sin pi by 2 1, and generalizing this value, or we write from here mod I, this is equal to mod I, this is equal to given by, this is 1, and argument of I, this is equal to pi by 2. So here we put in this position, we put log I, this is equal to, this is given by log I, means we put this value, or using this result we put here log of mod I plus plus I into 2p pi plus argument of I, and which is given by log of 1, this is 1, we already find here, and this is given by I into 2p pi plus pi by 2, because we already find log I, this is equal to pi by 2. So we get the value, this is 0, log 1 means 0, and this is I into 4p plus 1 into pi by 2, right? And another log I, for another log I, we write it as log I, this is also same value, but we use the integer other than p. Okay, because two integer may not be same, so we get from this result I into 2, this is 4q plus 1 into pi by 2. So the result is given by z equal to log I by log I. These two results cannot be cancelled out, because these two are the general value. So we put for the upper value z, this is equal to log I, means this I into 4p plus 1 into pi by 2, and for the lower value this is 4q plus 1 into pi by 2. Okay, pi by 2 cancel out, I cancel out, and getting the result 4p plus 1 by 4q plus 1. Okay, so we get z, this is equal to 4n plus 1 by 4m plus 1. We use n for p and m for q, because in the given proof it is given by m and n, where m and n belongs to z. Okay, and similar problem For the second, we write here. Z, this is equal to capital log of -1 base 2. And from the definition of exponential function, we may write 2 to the power z. This is equal to -1. Okay. Now taking logarithm, we get z into capital log of 2 plus this is equal to capital log of -1. Okay. Now if we write -1 as a complex number and -2 as a complex number, 2 as a complex number, we write this as, this is cos pi plus I sin pi. So mod of -1, this is 1, and argument of -1, this is pi. And similarly we can write this result as, this is given by cos 0 plus I sin 0 into 2 here. So mod of 2, this is equal to 2, and argument of 2, this is equal to 0. Now putting both the value of log 2 and log of -1, we get, this is z into, the value of log 2 is given by small log of 2 plus I into 2p pi plus 0, because the value of log 2 is given by this log of mod 2 plus I into 2n pi plus argument of z. Argument of z means argument of 2, this is 0. And the right side value is log of -1. It is also given by log of 1 plus I into 2q pi plus pi. Okay, because mod of -1, this is 1, and argument of -1, this is pi. So we get z, this is equal to, we first write the right side, that is this value, log 1 means 0, so we write I into 2q plus 1 into pi, taking common pi from this and this. By, we write this result, this is log 2 plus I into 2p pi. Okay. Now if we see the given answer, and this is write as in this form, but here it is used that q for n and p for n. So we replace or write the result as, this is 2n plus 1 into pi I by, this is log 2 plus, this is given by 2m pi I. Okay, where n and m belongs to z. This is the second answer, and here we write the first answer. Only the integers are changed from pq to mn. Here only integers are changed, q and p by p and m. We get the exact result as given in our problem. Very easy problem, but important problem of complex number. Okay, thank you for watching.